Hello, and welcome to our lecture on gastrulation. Now, the most important thing that ever happens to you is not birth, it's not marriage, it's not even death, it's gastrulation. And yet it might be something that you're not really familiar with. So obviously it's going to be very interesting to explore just what it actually means. So what we're going to do is to look at the formation of something called the primitive streak, and that gives rise to the main body axis. And at the same time, we go from having 2 body layers to 3 body layers. Just after this process, we also have neurulation, when the neural tube begins to form. And obviously, this is a key time in the formation of neural tube defects. And finally, we'll look briefly at twinning and the different varieties of twinning that you can get. So, first of all, gastrulation. And if we look at the embryos at the moment, we're studying the 2nd week after fertilization. And we have formation of the body cavities. So the upper cavity in green is the amniotic cavity, and the lower cavity in yellow is the yolk sac. And if you could imagine being a tiny diver, about 1 millimeter long, swimming in the green amniotic cavity and looking down at the floor, what you would see round about the 2nd week is formation of a little streak growing in from the margin, growing in from the edge of the amniotic cavity. And it's growing in the ectoderm, in that upper layer. And that little streak is called the primitive streak. And that is the formation of the main body axis. So round about 16 days after fertilization, we'd expect to see that in the floor of our amniotic cavity. And it doesn't look very impressive, but this is actually the moment of individuation. Up to now, you could have been twins or triplets or quads, but after this, then you're an individual for the first time. And therefore, it's a really significant moment in the process of human development. Also, of course, determines left and right, and head and tail. In the little diagram, head is towards the center of this area in the floor of the amniotic cavity, and tail is towards the edge. So all of these important axes are laid down at this particular time. It's a shallow depression. So if we were to section through it, it would appear like a little trough in the floor of the amniotic cavity. And it actually grows towards the midline. It grows towards the center of the amniotic cavity. And shortly, we'll look at a section through the part marked with the red line in the diagram. So at that point, we can imagine cutting through it, and we'll be able to look at it end on. So let's just review with labels what we've been looking at. You can see the amniotic cavity marked in green, the yolk sac is marked in yellow, and in between the two is the primitive ectoderm and the primitive endoderm, together called the bilaminar disc. The yolk sac is extending beneath the bilaminar disc. The amniotic cavity is extending above the bilaminar disc. The body stalk is what will be the umbilical cord in time. It's connecting it to the rest of the developing embryonic cavities. And we'll look at that again in more detail in lecture on formation of the placenta. Then we can see the primitive streak, and at the very tip of it, a structure called the primitive node. It's just the kind of starting point of the primitive streak. And we've labelled it cranial towards the head and caudal towards the tail. And these are the anatomical terms for those directions in the body. Now, I said that we were cutting a section through the red line 2 slides back. And this is what this section looks like. So up above, we have the ectoderm, epiblast as it's marked here. And down below, we have the endoderm. And what happens is that the cells are actually tracking towards the primitive streak. They're moving towards the primitive streak from either side. And when they reach the midline, when they reach the streak itself, that little depression that you can see, then what happens is that they dive down and then migrate out to the sides. They actually detach from the upper epiblast, the ectodermal layer, and then they migrate out again laterally. And that gives rise to a 3rd layer. And that 3rd layer, helpfully, is called mesoderm, the in-between derm layer. So we then have 3 layers, ectoderm on top, mesoderm in the middle, and endoderm underneath. and the cells are spreading out from the ectoderm to give rise to the mesoderm. And in a later lecture, we'll look at the different kinds of tissue that come from these three different body layers. So that's our third layer, the mesoderm, between the primitive ectoderm and the primitive endoderm.